Hello, Chem 120 problems on the board today that are going to show up on Canvas. Remember Canvas, you're supposed to be checking it all the time during the semester. Everything you need to pass this class is on Canvas if you do the work. So let's look at this problem right here. Using the balanced equation, write a complete ionic and net ionic equation for the following equation. That's a lot of equation. But anyway, the equation we're looking at is sodium sulfate. Remember, we have to name these things. We have to be able to name them and use the name of the metal and then the polyatomic ion, sodium sulfate, plus the name of the metal, calcium iodide. Remember, you change the name of the non-metal to I, and then forms calcium sulfate plus sodium iodide. All right, now what we have to look at is that this equation, the reactants are both in solution. This is an aqueous reaction. When things are aqueous and they involve a metal and a polyatomic ion, or a metal and a non-metal, they're ions when dissolved in solution. So to form the complete ionic equation, we have to separate the compounds. So we take the sodium, which comes apart. There's two sodiums, but they're not linked together, so they form individual sodium plus ions. The sulfate, which is linked together and forms a 2- anion in solution, plus the calcium, which forms a 2+ because it's an alkali earth metal, and all the alkali earth metals are 2+, where they form ions, plus 2 iodide minus anions. All right, so that's the reactant side of the complete ionic equation. When we get to the product side, we see that calcium sulfate has an S, which means it's a precipitate. So this changes, it precipitates out. So when it's still in the aqueous solution, it remains a solid in the complete ionic equation. However, the sodium iodide still remains in solution, so you need 2 sodium plus aqueous plus 2I minus aqueous. And that is our complete ionic equation. Now, to form the total net ionic equation, we look for the things that change, that are different on the reactant side than they are on the product side. So let's look at sodium. 2 sodium plus aqueous on the reactant side, 2 sodium plus aqueous on the product side. So we can cancel these out. These are our spectator ions if they don't change. Sulfate is aqueous on this side and solid on this side. So it remains. Calcium is aqueous on this side and solid on this side, so it remains. So let's bring these down. I always like to write the cation first. Now we have one remaining ion in solution, that's iodine. We look at that, and it's the same on the reactant side as it is on the product side, so that cancels out as a spectator ion. All right, so the only thing that's different here is the calcium sulfate, and it also is a solid. So what we've shown is that in this reaction, what actually occurs is calcium 2+ in the aqueous solution combines with sulfate 2- anion in the aqueous solution to form a solid precipitate, calcium sulfate, and that's our net ionic equation. So the complete ionic equation shows all the constituents when they're dissolved, plus the product, the precipitate, and then the spectator ions. The net ionic only shows the actual ions that participate in precipitation to form calcium sulfate. Thank you.